Hi everyone. In this solved problem, we're going to be determining a molecular and empirical formula from percent composition data. So we have to see what's given here. We know that 82.66% of my compound is carbon, and that's really all that's given. We're asked for the empirical formula and then given a molar mass, what is the molecular formula? So to start, we need to first assume a 100 gram sample and convert to masses of each individual element. So if there's 100 grams and 82.66% of that, we have 82.66 grams. And that's why we arbitrarily choose 100 grams, because my math works out really well. We also need to know that my percent of every element in this compound is going to add up to 100%. Since it only contains carbon and hydrogen, the percent hydrogen is going to be easy enough to calculate as 17.34 grams, or percent. And then once we convert that to grams, it will be 17.34 grams. Alright, then step 2 is to convert to moles. Ultimately, we're looking to get the mole ratio of these elements in my compound. So we use the molar mass. For carbon, is 12.101 grams per mole. So we'll get moles of carbon. This is 6.88 moles of carbon. And then for hydrogen, 17.34 grams of hydrogen divided by 1.008 grams per 1 mole. This comes out to be 17.20 moles of hydrogen. All right. Step 3 is to determine the mole ratio. And this is done by dividing by the smallest number. The smallest number here is 6.88. So I'm going to take 6.88 moles divided by 6.88 moles. This means I will have 1 carbon per every 2.5 hydrogens. And because we can't have half of an atom in a molecule, we must multiply this by some factor to give us whole numbers. When we have halves, we'll multiply by 2. If we have thirds, we'd multiply by 3. And if we have quarters, we would multiply by 4. So right now we have C1H2.5. And so to get whole numbers, I would multiply by 2. So I'm going to get C2H5. And this would be my empirical formula. Because we ultimately wanted to know a molecular formula, the next thing that we have to do is determine the multiplier. And that will give me the molecular formula. And to do this, we must compare the molecular weight, which was given as 58.12 grams per mole. So if we don't have a molecular weight, we cannot do this step. And we compare this to the empirical formula weight. And I'll abbreviate that EFW. And the empirical formula weight, of course, is calculated just like molecular weight. We find the number of carbons. I have 2 carbons times 12.01. That is 24.02 grams per mole. And then I have 5 hydrogens times 1.008 grams per mole. And that's a little bit more than 5 something something. If we add this up, we get 29.05 grams per mole. So now I'll compare. The multiplier that we need is equal to the molecular weight divided by the empirical formula weight. So I have 58.12 grams per mole divided by 29.05 grams per mole, and that equals 2. So that means that my multiplier is 2. I'm going to take my empirical formula, C2H5, and multiply it by 2, giving me C4H10 as my molecular formula. Of course, if your empirical formula weight is the same as your molecular weight, then you know your empirical formula and your molecular formula are the same.